All right, so today we're going to be doing volume. So volume is actually significantly easier than surface area. Our formulas are going to be a whole lot easier. We're not going to have to look at laying the figure out flat. And so we're again starting with the general prism. So I've got a couple of questions here again for you. What is capital B and what is lowercase b? And how can these prisms differ? And so this question's a repeat from the last video. So if you don't want to spoiler, pause the video. Okay, the main thing that is going to be different, hi baby, is that capital B is going to be the area of the base. This is a very subtle difference, so you've got to watch out. So this is the area, of the base. And so it is in square units. Lowercase b is going to be the length of the base edge in a two-dimensional figure. Sorry, my little pad here is a little short. The length of the base edge, and this is going to be two-dimensional, and it's also going to be in linear units. Okay, this one I forgot to mention. This one is 3D. This one is 2D. Okay. All right, so when we look at this, and this is going to be important as to why we have one formula for general prisms. The prisms can differ because their bases can be different shapes. So the prisms can differ because their bases can be different shapes. Let me get the S on there, sorry. All right, so when we look at this, and you can pick any one of these sides to be your base, it really doesn't matter. So just to be different, I think I'll pick this one. So let's say this is the base of my rectangular prism. So if this is the base, the capital B calculation I need to do off to the side here, the area of this base, of this rectangular shape at the bottom, would be 3 times 4, base times height, because it's a rectangular parallelogram. So 3 times 4 would give us 12. So then we come over here to our volume formula. Our area of our base would be 12. The definition of height is still very important. In a regular rectangular prism, it's going to form a 90-degree angle between the two bases. It's the line or edge that connects one base to the other. So since I said that was the base, this would be the opposite base, the parallel base, and the height has to be 6. So this would become 12 times 6, and then we'd multiply that out, and we'd find a volume of 72. This is in meters cubed, and the only thing you're going to put in the computer is 72. Now, I will try to put in Classroom some videos to kind of show you this, but the reason this works is, and I'm going to draw a really hideous little sketch here, is when we find the area of the base, we're figuring out how many square cubes would fit inside of the base of the figure. And then when we multiply it by the height, we're figuring out how many layers tall could it be. So we could have 1, 2, 3, 4, 5, 6. I know that's terrible, like drawing, but you get the idea. So we can stack up 6 layers of cubes that have 3 by 4 cubes in the layer, so a total of 12 cubes in each layer. And so that's where this formula is coming from. There are much better visual videos out there on YouTube where you can see that a little better. Let me make sure I didn't miss a slide. I think that was right. Sorry, guys. All right, so prism, pyramid. Okay, the next one we're looking at is the pyramid, and so we're going to see, again, a duplicate of the questions from before. So I've already kind of spoiled these, but if you want to pause and think about it again, by all means do. So what makes the pyramid different? It has only one base, and that one base is going to be parallel to a vertex. Excuse me. Okay, how many heights does the pyramid have? We talked about this before. We have the h value, which is the general height. And we have the L value, which is the lateral height. And lateral literally means side. All right, so in this case, in this formula, we're using the general height. So we talked about this a little bit in the last video. If I don't know the general height and I only know the lateral height, what I'm going to have to use is Pythagorean theorem. So I know this length right here is 7 because if the edge is 14, from the center to the edge is going to be 7. So now what we're looking at is we're looking at this right triangle, and I am going to do this with the shortcut for the sake of time. I feel confident we practiced this quite a bit. You should be able to solve a Pythagorean problem without much trouble. So this is the Pythagorean problem we have. This is the right triangle. We need to know this general height. So the thing that's important is identifying your hypotenuse. Across from the right angle always has to be C. So since we have C, we're not going to add, we're going to subtract. So to get the x value, it's going to be equal to the square root of 25 squared minus 7 squared. And again, if you can't do the shortcut, by all means, take your time. Do it the longer way. There's nothing wrong with that. But I'm going to do it this way for the sake of time. And I'm just keying this into my calculator really fast. In the PowerPoints, it's a little harder for me to show you guys my calculator as I do it. Again, I'm hoping that that shouldn't be a problem for you. Oh, for heaven's sake. It apparently is a problem for me to type that simple thing in. All right, so we get 24 when we do this. So if I didn't type anything in my calculator wrong, my answer for x is 24. So that means this general height right here is going to be 24 units. So now what I'm going to do is I'm going to plug into the formula. There are also a lot of neat videos that show you why the 1/3 happens. I promise if you take a pyramid with the same dimensions as a rectangular prism, and or a square prism in this case, and you fill it with water and you pour it into the prism, what's going to happen is it's going to take 3 pyramids to fill one prism. So its volume is 1/3 of the prism's volume, which is where this is coming from. We did the calculation for this base earlier, or well, we did it in the last video. It is a square pyramid. I forgot to fix it in this slideshow. So 14 times 14 would be my area of my base, so we could write that off to the side here. So 14 times 14, which would be 196. So we're going to do 1/3 times 196 times our general height of 24. I'm going to choose to do the 1/3 into the 24 because it will make my life easier. So that's going to make it 8. So the volume would be 196 times 8. And doing that in my head just saves me some time putting it in the calculator. You can actually type the whole thing in the calculator. um, totally up to you. So I end up with 1568 as my volume. So this is 1568. Again, this is in units cubed. But what we're going to put in our computers is only the number. Only the number. All right, we got a couple more to look at and then we'll be done. So we're back to the cylinder again. If you again think about that area of the base, tells you how many square or cube units will fit in the bottom layer, and then you're multiplying by the height, and that's going to give you the total number of cube units that fit inside the entire cylinder. The thing we've got again is our diameter is 20, so our radius is going to be 10. Now, the thing I asked you about for this one is what formula do you see that looks familiar? So if you look in here, I hope you see this. So this is the area of the circular base. So it's actually the same formula as the general prism. We're going to do the area of the base times the height. So what looks familiar? The area of the circular base. So now all I'm going to do is I'm going to say, okay, I'm going to do pi times my radius is 10 times my height of 20. And again, I could simplify that. Oh, 10 squared, my bad. I can simplify that by multiplying this out. So 10 squared is 100. 100 times 20 would be 2000. Oh my God, that's bad math. It would actually be 2000. So we're going to end up with 2000 pi So we're going to do 2000 times pi, and I'm just using the pi button in the calculator for this one. And when I round it, I get 6,283.19. So 6,283.19. So this would be your volume. This one, whoops, I need an approximate. This one would be volume in centimeters cubed. Again, the label, I'm going over it in the video, would normally go over it in instruction, but with those forms, we can't really enter in um, the label properly without having issues with the grading. So all we want in the form is the number. All right, two more. Next is the cone. The cone has a similar property again as the pyramid with that prism. The cone and the cylinder have very similar properties. If you look at the formula, you should actually be able to tell how much of the volume of the cylinder the cone occupies. And so you might look at that for a second, pause the video if you don't want a spoiler, but I'm going to tell you right now what it is. It is 1/3 of the volume of the cylinder. So that's where this 1/3 comes from. And then what you should see here is exactly the same formula we just used for the cylinder. It's just that we're only doing 1/3 of it. And again, you can find videos online that are going to show you people filling these cones with water, pouring them in the cylinders, and you can see very quickly that only 3 of them are needed to fill the entire cylinder. So we're just going to substitute in. So it's 1/3 times pi times our radius, which is 5 squared, times our height. And again, I've given you this problem. We don't know the height. We only know the lateral height. So we're going to have to solve another right triangle. Oh, that's a great line. We get 13 here, 5 here, x is here. I'll do this one a little bit longer. Across from the right angle is C. So then now if I was doing this properly, it would be 13 squared. 13 squared equals x squared plus 5 squared. Sorry, I forgot to turn my phone off. And then now we would work this. I'm going to just leave it like this to move it. You can simplify it first if you want, but I'd rather just do that really quickly so that I can get it done. And now I'm going to get x squared is equal to, I would just type that into your calculator. So you do 13 squared minus 5 squared, and it's actually going to work out pretty because I tried not to make my life miserable with this. And we end up with 144. How do I undo a square? I take a square root. The square root of 144 should be 12. So my height here is 12. So the general height is 12. That's what we're going to put here. And now we've just got to simplify this. So I'm going to do the 1/3 of 12, which would be 4. So I can get rid of that. The 5 squared is going to be 25. And then pi is just pi. 4 times 25 is going to be, whoops, let's try that again. Maybe. Oh, I'm too far down on my writing pad. 100 pi. So our volume is 100 pi, and then we're going to get an approximate value from that using our calculator and the pi button. Again, you definitely want to pay attention to the directions in the assignment because it's going to change up what you're going to have to do. So we end up with 314.16 if we're rounding to the 100th. You also want to watch your rounding direction to the 100th. This would be meters cubed. So this would be our final answer. My apologies again. I need to turn that off. So let me do that real quick. Pause, because they're going to start blowing up my phone. I already know. All right. So everybody understand hopefully how to do that one. Hope it wasn't too confusing. If it was, rewind the video, watch it again. Don't hesitate to contact for questions. All right, last one we're going to do volume 4 is the volume of the sphere. There are also lots of really fun videos on this one to figure out where this comes from. They actually use filling it with cones is one of the easiest ways to figure it out with the same dimensions. Um, and so it's kind of fun. I think that's this one. They do that as well. And it also has to do with the idea of what the height of this sphere would be. The height is actually going to be your diameter of your great circle, which is really kind of cool. So if you're interested in really seeing where the video comes from, I'm pressed for time, but I would definitely recommend you look at some of those videos. They probably actually do a lot better job than I would. All right, so 4/3 times pi. So this is a very simple substitution. times our radius cubed. So that's going to be times 3 to the third power. And so now what we're going to end up with is, I believe 3 to the third power is 27. 27 divided by 3 would be 9. 9 times 4 times pi. Let me make sure I'm not nuts with that. So 3 to the third power is 27. 27 divided by 3 is 9, and we end up with 9 times 4, which is 36 pi. All right, and then now we're going to do 36 pi or 36 times pi. I'm going to use the pi button again, and I end up with 113. So my volume ends up being 113.10. And in this case, and that's rounding it to the hundredth, if you round it to the hundredth and you get that, you can also put in the computer 113.1. Neither one of these should be counted incorrect. And so we didn't have a unit of measure, but again, this would be in cubic units. And so you just need to make sure you type in the number. We take the unnecessary zero because some people are very, very rigid in this. And if they say round to the hundredth, and you had to round this value, they want that zero there to indicate that. So it depends on the person. I'm not too picky. I take either one. Hope you enjoyed. I hope it helps. Good luck on volume.